Magic in your eyes. Magic in your eyes. Magic in your eyes.
Hi, welcome to Camtasia Thursday. Today we're going to be having a look at a small breadboard, otherwise known as an SK-10 board. And on the SK-10 board there are just 5 resistors. And those resistors are connected up, well, who knows how. It's a case of follow the wires and work out what the schematic circuit is. So let's go back to the pages on the computer. You can see here we've been playing in class with another complicated circuit that was a series parallel circuit. So we'll just go past that, and here we are. We've got the breadboard. And on the breadboard you can see the 5 resistors. We've got 220 ohms, 270 ohms, 1800 ohms, 560 ohms, and 330 ohms. And luckily, we have some different coloured connecting wires that take the ends of each resistor to somewhere else on the board. Now, the first time I tried to solve this after I was asked to in class, I went through and as well as trying to use colours, I actually wrote letters of the alphabet next to each pin, and I wrote those on my schematic diagram. And as I drew out the schematic diagram, I crossed out components and I checked it as I went. But after it was drawn, we found out that between B1 and H, as you can see here, 560 ohms, 330 ohms, we had a short circuit. And the class simply said, "You've made a mistake, that's wrong." And I said, "No, I don't think I've made a mistake. I think this is probably the circuit." So I then had people coming up and showing me what they had drawn and what their ideas were. And we got into a fairly large debate about this circuit. So I drew it again, and you can see here I ended up drawing it a little bit neater. 220 in parallel with 270, in parallel with 1800. Not sure why I've got this X here. Maybe that was somebody commented and I had to put that X there to cut a track. I can't remember now. But over here again, this is interesting, between B and the green wire at the bottom, 560 ohms, 330 ohms connected in series, and then a link of wire going across those two. So effectively a short circuit. So again, more debate about whether I've got this right. So I said, all right, look, give me a second. I'll copy the board down. I've pasted it back onto a clean section of my work pad here, and I've drawn it again more slowly and in a slightly different fashion. And you can see some red ticks on my diagram. That was I went through and checked each component off. And again, look what we came up with, this large redundant section in the circuit, 330 series with 560 ohms, but a short circuit across each. So I've written the word redundant next to those two. And that gave me my final circuit here, 220, 1800, 270 ohms. I'll just go to an inset video that I've got of this now. Okay, here's the board that we had to work with. This was the question, and I'm just doing this as a small practical layout. So again, to have a quick look at the board, 220, 270, 1.8K, 560 ohm, 330 ohm, and beautiful coloured wires connecting them up. Well, I can connect them up, but I unfortunately only had black wire. So here's the connected up layout. And again, there's my 220 ohm, 270, 1.8K, 560 ohm, and 330 ohms hiding down here in the corner. And I was careful to follow the exact pin layout as per the breadboard sketch. And then if I get the multimeter, and there's our meter, it's on the resistance range. And here's the input to the circuit, so between there, and it's measuring 114 ohms. In fact, I can get better resolution there by going down to the 200 ohm range on this manual ranging meter. It's saying, well, exactly 114 ohms according to this, 113.9 maybe, but then again, how much resistance is there in the leads? These leads are saying around about 0.8 of an ohm, 0.9 of an ohm, so I'm going to call that about 113 ohms across there. And that again proves that the circuit layout is correct the way I've done it. So just to wrap up, doing the maths on that circuit, because we did see on the multimeter that we had 113 ohms, so that was 220. Let's just draw these numbers in. 220, and some of the reciprocals, that'll be 1 over, plus 1 on 270, plus 1 on 1800 ohms. And then of course that answer we have to go 1 on, so I'll just put there 1 on X, and that comes out to 113.57 ohms. Well, we got 114 originally, then we went down to 100 and we looked at the resistance in the leads. That was about 0.8 or 0.9 of an ohms. So I said, okay, so we're back down towards 113. There you are, we're smack in between 113 and 114 ohms. Perhaps with a better quality meter, we would have been a little bit closer. Just to show you the meter that I was using, it's a Digitech meter, and the Digitech meter is not a terribly expensive meter, and that's why we probably do have quite a bit of resistance between not only the leads, but the connections between the terminals on the meter front to the printed circuit board inside the meter as well. But it's good enough for most measurements that we would ever do. All right, hope that helps. If I get a chance, I'll make another video about the next question in the homework assignment. However, the homework assignment was a 2-week homework assignment, and you've still got plenty of time left to finish off that homework. So this has been Greg Moore for TAFE New South Wales. See you next time. Bye.